to test h sub 0 where mu is equal to 20 versus h sub 1 where mu is less than 20, a simple random sample of size n equals 19 is obtained from a population that is known to be normally distributed. If x bar equals 18.5 and s equals 4.2, compute the test statistic. So we first need to check our conditions. So we notice that we have a sample size that is too small. So typically anything under 30 is too small. So then we need to make sure that we have a population that is normally distributed. So it tells us we have a population that is known to be normally distributed. So we're good to go there. So we can compute our test statistic. So we're working with t, and that's because we know the sample standard deviation and not the population standard deviation. So t sub 0 is x bar minus mu sub 0 divided by s divided by the square root of n. So it looks similar to something we're working with in the sampling distribution for x bar, right? So let's plug everything in and then we'll use StatCrunch to compute the test statistic so we can see how those correspond here. Alright, so I'm going to plug all this in into my calculator. So parenthesis 18.5 minus 20 divided by parenthesis 4.2 divided by the square root of 19, close parentheses. We get approximately negative 1.557. Right, so that's our test statistic. So we're going to come over to StatCrunch and compute our test statistic here. So we're going to t-stats, one sample with summary. So our sample mean here is 18.5. Our sample standard deviation is 4.2. And our sample size is 19. And our hypothesis test, the null is where mu equals 20. And the alternative is where mu is less than 20. We're going to hit compute here. We see that we get our negative 1.557. So we're looking at the t-stat as our test statistic here. Okay. So now we want to draw a t-distribution that represents the p-value shaded and then the t-distribution that depicts the critical region if they decide to test at the alpha equals 0.85 level. So our p-value goes with our test statistic. And I think, yep, okay. So I'm going to snip these. Look at an identical graph. So negative 1.57, so about right here. Alright, so this is our p-value. That shaded region there is our p-value. So that there is the p-value. Right, so again, the p-value is a probability. And then we want to look at our critical region. So we're working with less than, so we're working with a left-tailed test since it's less than, and we need to determine two things. So alpha is 0.05, right, and our degrees of freedom, so those are two things we need to know. So our degrees of freedom is n minus 1, n is 19, so our degrees of freedom is 18. So we can use StatCrunch to help us find this. So we're going to go to Stat and then Calculators and T, and our degrees of freedom is 18, and we want less than, and we know that the probability here is 0.05, right? So, oops. So I'm going to hit compute here, and then there is my critical value. So my critical value is negative 1.734. So negative 1.734 is my critical value. So just a little bit further over. So this is my critical region here. This is the critical region. So we can see our test statistic and critical value are pretty close together. So now it says approximate the p-value. And this is, if you're using the table, you won't get an exact value, it's something close. But in StatCrunch, we can get the exact p-value. So if I come back over here and pull up my results, one sample t summary, and go over, we get our p-value here, which is 0.0685. 0.0685. Right, so our p-value is between these two values, right? So again, that's mainly if you're using the table, you can only get an approximate answer, but we can get an exact answer using StatCrunch. And then we want to know if the researcher decides to test at the alpha equals 0.05 level of significance, whether they reject. So again, we would compare the p-value to alpha. So our p-value here with alpha, and 0.06 is just a little bit greater than 0.05. So since it's greater, then we do not reject. The null hypothesis, right? So that's what we would have there.